4.2, multiplying and dividing rational expressions. Think and refer back to the 4.1 notes. So on this one, normally in 4.1, we only see the one fraction, so we would just simplify the numerator and denominator, cancel out what they have in common. When you multiply rational expressions and simplify, this situation happens where we have a rational expression on the left, a rational expression on the right, multiplication down in the middle. Number everything in order. So I'm going to go 1, 2, 3, 4. I'm going to work it out in parts. So we're going to look at number 1. It says x plus 3. There is nothing to factor out from it, so it stays x plus 3. We go to number 2. It's x squared minus 9. Well, x squared minus 9 is our difference of squares. So that breaks down into x plus 3, x minus 3. We go to the third one. It says x minus 3. Well, x minus 3 stays x minus 3. And then number 4 says x plus 1, and that also stays x plus 1. So remember the order that we numbered them. We numbered them 1, 2, 3, and 4, and we're going to put them back together in that same order. So the number 1, we have x plus 3. Number 2 became x plus 3, x minus 3. Number 3 stayed x minus 3, and number 4 is x plus 1. Now cancel out your like terms. So x plus 3 and x plus 3 cancels. X minus 3 and x minus 3 cancels, leaving with only a denominator of x plus 1. Here's the situation. When the numerator is gone completely, you must establish a value. It's a value of 1. So your numerator becomes a 1 since everything canceled out. So your final answer is going to be 1 over x plus 1. Next example. Okay, so in this one again, it's a little bit more in depth. So we have x squared plus 5x plus 6 divided by x squared plus 5x plus 4 multiplied by x squared plus 6x plus 5 over x squared plus 8x plus 12. Again, do the same situation. Number 1, 2, 3, 4. Okay, we're going to start with number 1. So it's x squared plus 5x plus 6. We're just going to factor it. Remember, numbers that multiply to 6 that add to 5 are only 3 and 2. And in order to be positive 5 and positive 6, they're both positive. Then we go to number 2. It's x squared plus 5x plus 4. Again, we are factoring. Split your variables. Has to multiply to be 4 and add to 5. Well, 4 to get to 5, it can only be 4 and 1, and they are both positive. Then we go to number 3, which says x squared plus 6x plus 5. Again, factor, x split your variables, has to multiply to 5 and add to 6. Well, 5 and 1 multiply to 5 and add to 6. And then we go to number 4, x squared plus 8x plus 12. Factored out, split your variable x's. It has to multiply to 12 and add to 8. Well, 12 is 6 and 2, 3 and 4. 6 and 2 can give us 8, so they're both positive. And then put it back together in the order that we factored, 1, 2, 3, and 4. So number 1 was x plus 3, x plus 2. Number 2, x plus 5, x plus 1. Then bring number 3 right beside number 1. So x plus 4, x plus 1. And then x plus 6, x plus 2. Once everything is factored, cancel out your like terms. So I see an x plus 1 and an x plus 1, x plus 2, x plus 2. Nothing else factors out, and you're left with x plus 3 times x plus 4 over x plus 5 times x plus 6. Next example. We're going to continue again. Number them 1, 2, 3, 4. We're going to work with number 1. It says x cubed plus 216. Now, here's the situation here. It's a cubic function. So remember, you need to refer back to your cube roots. So a cubed plus b cubed is your a plus b, a squared minus ab plus b squared pattern. If it had been a minus sign, a cubed minus b cubed. You are just flipping the sign. So it's a squared plus ab plus b squared. So on the first one, you need to make it in cube power. So power of 3 plus power of 3. X to the power of 3 gives us x cubed, and a number that gives us a number raised to a power of 3, that's 216. Remember, that's the number 6. So here's our a, here's the b. So we become x plus 6, and then x squared minus 6x plus 36. So that's number 1. Then we go to number 2. Number 2 is x squared minus 36. Remember, this is difference of squares. That becomes your x plus 6, x minus 6 pattern. Then we look at number 3, x squared plus 12x plus 36. So when we look at this, has to multiply to 36. So we have our 4 times 9, 6 times 6, 12 times 3, 1 times 36, but it has to add to 12 in the middle. Well, 6 and 6. It's x plus 6, x plus 6. Then we go to number 4. It says x squared minus 6x plus 36. Now on this one, has to multiply to 36 and add to negative 6. So if we've already used this one, let's look at our values. So 4 and 9, 6 and 6, 12 and 3, 1 and 36. And it has to add to a negative, multiply to be positive, and negative. So if I change all these to negative values, that's a negative 13, negative 12, negative 15, negative 37. We will never reach negative 6. So this is D and E for this one. So we can't factor that one out. So we would leave it as is. That would be our answer. So now let's put everything back in order. 1, 2, 3, 4. Number 1 was x plus 6, x squared minus 6x plus 36. Number 2 was your difference of squares pieces, x plus 6, x minus 6. Number 3 was your factored pieces of x plus 6, x plus 6. And then number 4 was the one that did not factor, x squared minus 6x plus 36. Cancel out all common pieces. Well, x plus 6 and x plus 6. X squared minus 6x plus 36 and the denominator. And then we have nothing else left over that factored out. We only factored out this pairing right here. So you're left with x plus 6, x plus 6 over x minus 6. You can either input it as such or use this as a power of 2. So this would be your final piece. Next example happens to deal with division. So multiplication, we just number them 1, 2, 3, and 4. When we divide factors, there's one extra step you do. Think of back in your factoring days and fractions. When you divide fractions, you had to flip it, keep it, change it, skip, flip, multiply, whichever situation you happen to have. So here's our original. There's my division bar and that. Second part we're dividing by. So we need to flip it first. So the first thing we're going to do is rewrite it as x minus 2. Keep the first fraction as is. Flip the second one, so become x plus 5 in the numerator now, x minus 1 in the denominator. Change your division to a multiplication dot. Now we can number them 1, 2, 3, 4. So here we're going to go 1, 2, 3, 4. So we're going to work with number 1 first. X minus 2 stayed x minus 2. Number 2 is x squared plus 3x minus 10. Has to multiply to be 10. Well, the only numbers I can think of are 1 and 10 and 5 and 2 and give us a 3. So 5 and 2 can get us to a 3. Has to give you negative 10 and add a positive 3. So the 5 is positive, the 2 is negative. Then we go to number 3. Now number 3 is our x plus 5. Remember, we flipped them. So it stayed x plus 5. Number 4, when we flipped, was x minus 1. And it stays x minus 1. We are going to basically group it back together. So 1, 2, 3, 4. So we see x minus 2, 1, 2. So the 2 became our x plus 5, x minus 2. Our 3 is our x plus 5. And our 4 is x minus 1. Cancel out their like terms. So x minus 2 and x minus 2, x and 5, x plus 5. The numerator went away. But remember, as a placeholder, we put a 1. So this is our final answer. Moving on to our next example. Again, it's division. So remember, we need to keep the first with the second. So 2x plus 9x plus 4. We're just rewriting our problem first before we start. Multiplication dot now, and flip numerator and denominator of the second one. So 2x squared minus 5x plus 2 goes on the top. X squared plus 7x plus 12 goes on the bottom. Once you've done that, then number your pieces 1, 2, 3, 4. 1, 2, 3, 4. And we're going to work with number 1 first. It's 2x squared plus 9x plus 4. So we're going to do 2 parentheses here. First leading coefficients 2x, 2x, and then 2 times the 4 is an 8. Has to multiply to 8 and add to 9. Well, that's only 1 and 8. Add 1, add 8. Divide by the GCF. So we have 2x plus 1 times x plus 4 for number 1. Then we go to number 2. Number 2 says x squared plus 2x minus 8. Again, we factor. So x and x, 4 and 2 give us 8. To give us a positive 2, the 4 had to be positive, the 2 had to be negative. We go to number 3. Number 3 says 2x squared minus 5x plus 2. Again, we are going Colombian. 2 parentheses, dump the coefficient 2x into both of them. And then 2 times the 1 is a 4. Has to multiply to positive 4 and add negative 5. Well, 1 and 4 if they are both negative. So negative 1, negative 4. Divide these by 2 and you have 2x minus 1 slide down, x minus 2. Then we go to number 4. Number 4 has x squared plus 7x plus 12. So x and x has to multiply to 12 and add to 7. Well, 4 and 3 are our only values that can do that. So they're both plus. Now let's put them back together. 1, 2, 3, and 4. So number 1 was 2x plus 1, x plus 4. Number 2 was x plus 4, x minus 2. 3, 2x minus 1, x minus 2. And number 4 was x plus 4, x plus 3. Cancel out your like terms. So we see x plus 4 and x plus 4. An x minus 2 and an x minus 2. So you're left with 2x plus 1, 2x minus 1 over x plus 4, x plus 3. Now, depending on which system you have, you may enter them. I would suggest entering your solution like this, unless it wants it in an expanded form, but it would tell you that they want an expanded form. Last example, it says 64y cubed plus 27 over, again, we are dividing. So we look at this problem. First thing we want to do is keep it, flip it, change it. So 64y cubed plus 27, kept the first one, kept the denominator, changed to multiplication, flipped numerator and denominator. So 9y squared minus 33y plus 1 on top, 16y squared minus 9 on the bottom. Once you've done that, then number it 1, 2, 3, 4. We're going to work with number 1 first. It's 64y cubed plus 27, which means we're using sum of cubes again. Remember, that's when you put everything in parentheses. Power of 3. So a number that multiplied 3 times in a row that gives you 64 is the number 4, and then a y. 27 is a 3. So now we have our A and B. plug it into the pattern that we've established previously. So we know that it becomes 4y plus 3. Then it's square the 4y, you get 16y squared, minus sign, these two multiply, so you get 12y, and then b squared, which is 3 squared, which is a 9. So that's what it becomes here. Now when we go to the next one, we go to number 2. So we see 27y cubed plus 1, another cubic pattern. Again, power of 3. A number that multiplies to 27 is a 3 with a y. A 1 is still a 1. So there is your A and your B. Again, the pattern, 3y plus 1. So square the 3y, we get 9y squared. Minus sign, 3 and 1 is 3y. 1 squared is a 1. We go to the third one. It is 9y squared minus 3y plus 1. We are going to attempt to see if it factors out. So again, go straight to 2 bubbles. 9y, so a 9y, 9 times 1 is 9. Has to multiply to 9 and add to -3. So when we look at this, there are no numbers that multiply to 9 that add to -3 because 9 is 3 and 3. When they're both negative, -1 and -9 does not factor. So it stays as is. So we are left as 9y squared minus 3y plus 1. And then we go to number 4, which says 16y squared minus 9. When I look at this, 2 terms, minus sign, power of 2, and 16 and 9 are perfect numbers, which I can take the square root of. This is difference of squares. So that is a plus minus situation. Square root of 16 is a 4 with a y for both of them. Square root of 9 is a 3 for both of them. So now since we have our 1, 2, 3, and 4, we're going to bring it back together. Our 1 was 4y plus 3, 16y squared minus 12y plus 9. Our 2 was 3y plus 1, 9y squared minus 3y plus 1. Our 3 did not factor. It's 9y squared minus 3y plus 1. And our 4th was the difference of squares. So 4y plus 3, 4y minus 3. Once everything is factored, cancel out their like terms. Well, 4y plus 3, 4y plus 3. 9y squared minus 3y plus 1 with the bottom piece. Nothing else factors out, so you're left with 16y squared minus 12y plus 9 in the numerator line. 3y plus 1 times 4y minus 3 in the denominator line.